Right, in this video, we're going to be going over section 8.4, which are trig ratios, which are very important. We've already gone over the regular trig ratios, and we're going to be going over the inverse trig functions or inverse trig ratios in this video. First example here, I just want to review the regular trig ratios and how we use them, and then we'll move on. So don't forget your acronym SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and the tangent is the opposite over adjacent. So in this case, we have an angle. We have its adjacent side, or we're solving for the adjacent side, and we are given the hypotenuse. So we want to use the trig ratio that includes both the adjacent and the hypotenuse, which if you look at your acronym, that would be the cosine, because that cosine has the, the cosine has the, the cosine has the adjacent over the hypotenuse. So the way we're going to set this up, I know you can see your answer down here already, is we're going to say the cosine of my angle, and my angle in this case is 41, is equal to the adjacent side over the hypotenuse side. So we would just solve this for x. This is very easy to solve for x. All you got to do is multiply both sides by 32. And so my answer will be 32 times the cosine of 41. And so you're going to need your calculator for that. One thing to just make sure, not sure if we talked about this yet, but there is a mode button on your calculator with a bunch of settings. You want to make sure that this third setting down here with radians and degrees, you want to make sure you have that set on degrees. We haven't learned about radians yet, but we are measuring things in degrees. This is 41 degrees. So make sure that setting is in degrees first before you type your answer, or else it'll come out wrong. So our answer should be 32 times the cosine of 41, close parenthesis, hit enter. We get 24.15. That's exactly what we wanted. Let me just show you what that comes out to if we were in radians instead. So if we had it in radians by accident, we typed the same thing, you're going to get negative 31 point, you're going to get not even close. So again, make sure your calculator is set into degrees. By default, it will be in radians, so you will have to make sure that you do that just every time before you answer these questions. So that is just regular trig ratios. Let's clear these objects, and let's move on to inverse trig functions. All right, so when do we use inverse trig functions? We use them when we know the side lengths, but we do not know the angles. So this would be used when we have to solve for the angle. So in that previous example, we knew the angle was 41 degrees already, so we didn't have to solve for the angle. We had to solve for the side length. When we have to solve for the angle, we have to use the inverse trig ratios. And all these do is they undo the regular trig ratios. And I'll kind of show you what that means. So this will be used to solve something. If you had angle A and you're trying to find that measure of angle A, this is cosine, so SOHCAHTOA. This would be adjacent over hypotenuse. So this would be an example where the adjacent side is 5, the hypotenuse is 12, and we want to know what that angle is in that corner. So you would set it up like this, but until now, you don't have any way to get A by itself if there's cosine out front. So we're going to be able to use inverse trig ratios to get rid of that cosine to be able to solve for the angle. So let's move on. All right, so here we have an example, and it wants me to find the measure of angle P. So the angle we are referring to here is this angle here. So I've got to recognize which side lengths do I have. I have the adjacent side, and I have the hypotenuse side. So again, if you're using your acronym SOHCAHTOA, the middle of that, SOHCAHTOA, is the trig ratio that has the adjacent and the hypotenuse. So we would want to use cosine for this. So we're going to say cosine of my angle, which I don't know, but I know it's P. It's the name of the angle. Has to be the adjacent over the hypotenuse. So it has to be 13 over 19. All right. And again, until now, we don't have a way to find P if you have cosine in front. So what we're going to do is we're going to use the inverse trig ratio to get rid of the cosine. So if you look on your calculator, you have a little cosine and it says -1 on it. So if we do the cosine inverse of both sides, cos, cosine inverse of both sides. What's going to happen over here is I have cosine inverse times cosine. Anything times its inverse cancels each other out. We're just left with p. So all I got to do is take this right side, and I have to type cosine inverse of 13 over 19 into my calculator, and I'm going to have that angle. So let's do that. Where's cosine inverse? Well, it's right on the cosine button, but you just click the second button first. So there's your cosine inverse. It is 13 over 19. We're going to hit enter, and we get 46.82. So we just round, or 8.3, I guess. So we'll round that, 46.83. Okay. And that is, I mean, that's how you use your inverse trig ratios. It did say round to the nearest tenth, so I rounded it too far, but it would just be 46.8. Let's check our work. Clear objects. So we have to use cosine. We're going to use cosine inverse of 13 over 19. Use a calculator. This goes through and tells you which buttons to push. All right, measure of angle D. So this is not going to be using cosine because if we're talking about angle D, we don't have the adjacent, we have the opposite. So opposite over hypotenuse, that would be the sine. So katoa, right? Sine is opposite over hypotenuse. So I want to use the sine. So this is going to be sine of my angle D must be equal to the opposite over the hypotenuse. And if I'm solving for D, I just have to do my inverse trig ratio to both sides. So I'm going to do the inverse sine of both sides. And so my answer is going to be the inverse sine of 16 over 23. So inverse sine of 16 over 23, close parenthesis, hit enter, and we get 44.07, which would round up to 44.1. So it looks like A is going to be our correct answer there. I just want to show you what might happen if you forget to do sine inverse. So let's say you just, you were rushing through these. You were like, okay, that's opposite of our hypotenuse, so we're going to do sine 16 over 23. Close it, hit enter. This should be a red flag, right? Because 0.01 degree angle is not really even close to like a measure of an angle. Like that is extremely small. So if you see something extremely small or something that just seems off, just make sure that you're doing the sine inverse and not the regular sine. All right, answer is A. Great. See if we can get a tangent one. Okay, here's a tangent one. Solve the right triangle. Round the side measures to the nearest hundredth and angle measures to the nearest degree. Okay, so to solve for the hypotenuse, we just have to do Pythagorean theorem. So this is going to be the square root of, and then 7 squared plus 4 squared. So 7 squared is 49. Write these off to the side here. 49. 4 squared is 16. And so if you add those together, you get 65. So the hypotenuse is the square root of 65. Don't think that simplifies because that's 5 times 13. So we'll just leave that there. So there's my side length. And then I just need to find both angles. And at this point, since I have all 3 side lengths, I could use really any trig ratio I wanted to. To eliminate having to type this number in the calculator, I'm just going to be using tangent for both of these. So if I'm finding the measure of angle A, the measure of angle A, or the tangent of A, is equal to opposite over hypotenuse. So that's the TOA part of your acronym. TOA, opposite over hypotenuse. This would be 4 over 7. So to find A, we're going to be doing tan inverse of 4 over 7. Let's get our calculator. Tan inverse, tangent inverse of 4 over 7, second tangent, 4 over 7, close parenthesis. We get 29.7 if we're rounding to the, it says round to the nearest degree. So 20, or round it up to 30. So we'll round this up to 30 degrees. So theoretically, we should know that B will round up to 60, but just for the purpose of teaching trig ratios, we will go ahead and do the tangent for angle B as well. So tangent of B is opposite over hypotenuse. Let's see if I can get this calculator out of the way. The opposite in this case would be 7. The adjacent would be 4. So we're just doing tan inverse of 7 over 4. Tan inverse 7 over 4. And again, this should be slightly over 60, but it should round to 60. So that's 60.3, and again, that would round to 60 since this said to round to the nearest degree. So angle B 60 degrees, angle A 30 degrees, and the hypotenuse would be square root of 65. Found that by doing the Pythagorean theorem. So let's see the way they did it. So they found angle A first by doing tan inverse. That's what we did. Okay, so they just used complementary angles, so that should be approximately 60. And did they find AB by using the Pythagorean theorem? They did, so they should get, again, the square root of 65 as their answer. Okay, let's do one more question here. Solve the right triangle. So a good way, multiple choice tactic to use would be to look to see the differences between the question that way, and then find the first thing that can help me eliminate the most answers to start. So if you look, they both have 36 and 54 as their angle measures. So some of them are backwards. So we could either find A or find B first and eliminate 2. Also, they have 2 different lengths for AB, so either 13.6 or 16.3. So solving this in any particular order is not really going to make it any faster to eliminate some of these, so it doesn't really matter which way we do it. I'll use my calculator. I'll go ahead and find the hypotenuse since that is the fastest way. That'll help me eliminate some. That should be 8 squared plus 11 squared, and then square root both sides. So square root of 8 squared plus 11 squared is, close parenthesis, is 13.6. Okay, so we can take our thing. We can eliminate C and D because they have the wrong side length. And then we'll just go ahead and solve for one of these angles and we'll figure it out. So I'm going to solve for angle A. Angle A should be tangent of, and tangent is opposite over hypotenuse. Not opposite over hypotenuse, sorry. Tangent is opposite over adjacent. So I want to just do tan inverse of opposite over adjacent, and that will get me my angle measure. So we get out our calculator, tan inverse of 11 over 8. It's 53.97, so that rounds to 54. So angle A should be 54. So it looks like B should be our correct answer here. All right, and I think that's gonna do it for our inverse tangent, our inverse trig ratios. Thank you for watching. Like and subscribe to the channel.